6.4, translations of the graphs of sine and cosine functions. Basically what we're going to do is we're going to shift things up, down, left, and right. And so go back to your algebra class and remember when you had like a parabola shape, all right? Y equals x squared we knew was a parabola shape. And then at some point you learned how to shift that parabola shape, and you might have said y equals quantity x minus 4 squared plus 7. And you were supposed to remember that this right here was a shift right 4, and this meant you shifted the whole thing up 7. It was still the same shape. It was still that same parabola shape. We just shifted the whole graph, the whole curve, right 4 and up 7. We're going to do the same thing, but now we're going to be dealing with sines and cosines. So I'm going to skip a few slides and go get the directions. So skip forward about 4 or 5 slides. These are the directions that I want you to follow for graphing these sine and cosine functions. It's really very similar to the last lesson. Step 1, ignore the shifting. So I'm just going to kind of take it completely out of the problem and graph the non-shifted function. All right. Find the period, which is the same thing as before, 2 pi over b, and the amplitude is going to be a. So find that of the non-shifted function. I'm going to take the shifting out of the equation and just look at the non-shifted, and I'm going to do the exact same thing. Step 2, mark that period on the x-axis. So here's going to be your period. You cut it in half, mark it into 4 equal parts. Cut it in half and half again. So I'm doing the exact same thing. Step 3, use the unit circle to evaluate the function. So I'm still going back to that unit circle. Make sure you know those 4 points. Unit circle, we want the quadrantal points. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. We want those 4 points. And then after we draw, we can draw a curve through that if we want to, but step 4, we're going to shift all of the points as described. So maybe we have to go up, down, left, right, something like that. Maybe we go right 4 and up 7, like that example I gave a minute ago. It's probably going to have a pi in there somehow, though. So now let's go back and let's look at example 1. Example 1. So, I'm going to change this one slightly. I don't like that 3. It makes the numbers harder than they need to be. So this 3, I'm going to change that to a 2. That ought to make this easier on us, easier to understand, and that's what's important. Okay. So x minus pi over 2 there, that's the change. I want you to get to the point where you can just recognize that that's right. Pi over 2. Something is getting shifted to the right by pi over 2. Algebraically, sometimes I think it helps to think about finding the 0. If you think about where this expression would equal 0, that's kind of why it's right and not left. That's why it's like the opposite. You'd add, you add this over, you're going to get x equals pi over 2. You don't really need to do that step. That can be a thought process in your head if you want. But that's kind of why this is right, pi over 2, is because we're finding what's going to make that 0 out. All right. So hang on to that. That's your shift. It's going to be shifted to the right by pi over 2. But other than that, I want to take the shifting out and just look at the equation that says y equals sine x. If I took that minus pi over 2 out, if I took the shifting out completely, I would have this, which is what we did in the last lesson. We graphed plain old sine functions. And so what we did was we said this was a, that's the amplitude of 1. And then here's your b number. And so we calculated the period based off that, 2 pi over b. In this case, 2 pi over 1. The period is 2 pi. Okay? So I'm talking about the non-shifted function right now. Okay, the non-shifted function has an amplitude of 1 and a period of 2 pi. So let's do what we were doing. Okay, what we did before was we took that period of 2 pi and we marked it on the graph. And we cut it in half and half again. So kind of make those little tick marks there. You're cutting it into 4 equal spaces, half and half again. You look at your unit circle. And you go around to your y numbers because this is a sine function and sine goes with y. So we're looking at our y numbers and we see the first y number is going to be 0. So sine 0 is 0. I know there would be a dot right there. Now here's what I'm going to do, okay? I'm going to put an x right there. Instead of a point, I'm going to put an x right there. That's going to be kind of my signal to myself that this isn't the real function. This is before the shifting. Okay, it doesn't really matter. You can put a dot there if you want to, but I'm going to put an x there. My next y value signifies sine pi over 2, and sine pi over 2 is equal to 1 in this case. So I'm going to put a little x right there at 1. Sine pi is 0, so I'm going back to 0 at pi. Sine 3 pi over 2 is negative 1. So I'm going to go down here. And then, of course, we get back to sine 2 pi is 0. Now, if you want, you can draw kind of a dotted line or a light sine curve right there. But that's not my answer. That's the non-shifted graph, okay? My real graph is supposed to be sine of quantity x minus pi over 2, and that means I have to take all of my dots and shift them to the right by pi over 2. So if you take that first black x and shift it right pi over 2, notice that pi over 2 is 2 tick marks on our graph, okay? So we're not just shifting right 2 tick marks, we're shifting to the right 2 tick marks because that signifies pi over 2. So I'm going to go right pi over 2, and then the second x go right pi over 2, and then the third x goes to here, and the fourth x goes to here, and the fifth x goes to here. So my real curve that I want is right there. Okay? Now go ahead and extend your pattern. If you continue the pattern, we're going to keep going up to there and down to, up to, down to. Okay. So keep in mind that blue dotted line there is not part of the answer. It's the red and it's the purple. Okay, this problem specifically says over 1 period, so if that's what your problem would say, then we only need the red part. That's 1 period of the curve. But typically when I give you graph paper like this, I'm going to want you to fill it up. Okay. Number 2 is a cosine curve. So what I want to do is kind of ignore the shifting. If you look at this shifting, we know we're going to shift this curve to the left pi over 4, all right? And it has to do with making a 0. If you need to think about it this way, x plus pi over 4 equals 0. You'd subtract the pi over 4 over. I really don't want to have to do this. This is maybe my thought process, but I really don't need to do this to see that we're going to shift to the left pi over 4. Now down on your graph, you should know that pi over 4 is equivalent to 1 tick mark. So when I say I'm shifting left pi over 4 on this graph paper, that means left 1 tick mark. So in order to do this, I want to ignore the shifting and just look at the equation without shifting. Y equals 3 cosine x. Without any shifting, that's what I would have. So let's do this. We would know the amplitude is 3, and the period is 2 pi over b, but in this case that b is 1. So we're going to have a period of 2 pi. Okay? Period of 2 pi. What we always do is mark that period of 2 pi, cut it in half, and half again. You're trying to make 4 equal marks. So ignore my black tick mark of pi over 4 and look at the green ones. You've got a period of 2 pi marked, cut it in half, and half again. Those are my marks. Now, the way I look at it, go back to that circle. This is your unit circle, and this is how you're going to figure out all of the numbers pretty much without having to do a whole lot of calculations. Okay, so we want the first cosine number. The first cosine number, or cosine 0, is 1, but then we've got to multiply it times this 3. So we're actually going to start up at 3. I'm going to put an X there because that's not going to be my answer. That's just my pre-shifted function. So then go to pi over 2. Okay, pi over 2, if I did cosine of pi over 2, I'm going to get 0 times 3 because it's my amplitude number, my multiplier, and I'm going to get 0. So there's a point right there. Next at pi, your cosine is going to be -1 times 3 is -3 at pi. At 3 pi over 2, we have 0 times 3 is 0, and back to 2 pi, we have 1 times 3 is 3. So you can draw a dotted line through there to show the curve, but I'm not going to. I want to show the shifted curve. My shifted curve and my final answer would be what I would get when I shift all of these points to the left pi over 4. Now remember, left pi over 4 means left 1 tick mark. So take each of your x's and shift them to the left by 1 tick mark, or pi over 4. And that's going to be your cosine wave with the phase shift. I would fill in the pattern. Notice you can go down 3 and over 2 tick marks, and down 3 and over 2 tick marks here and here, here, finish it with a nice smooth curve through. If your directions only wanted 1 full period, you could maybe only draw this, and that would be fine. Sometimes they only ask you for 1 full period. But on my assignments, I probably want you to fill in the whole graph. Number 3 is another cosine graph, and I'm going to change this problem. I don't like that 3, so change that 3 into a 2. I think it'll make you understand the problem a little bit better. So let's look at the shifting. The shifting is going to be, think about it here, what makes this equal 0? If you subtract pi over and then divide by 2. That right there shows you the shifting is to the left by pi over 2. Okay, we're shifting this thing left pi over 2, so ignore the shifting for a second. And the equation would be y equals negative cosine 2x. I leave the 2 in there, and that's gonna help me find the period. I need that 2 to find the period. You can see the amplitude is 2 with a flip, and the period is going to be 2 pi over 2, which is pi. All right. So we've got a cosine graph. It's got an amplitude 2 with a flip and a period of pi. It's going to be shifted to the left pi over 2, but we'll worry about that at the end. Excuse me. So mark off that period of pi. Cut it in half and half again. We're pretty much doing that every time. We're trying to get it back to this circle. By doing that, we always take it back to these numbers in the circle, and we kind of make our problem a shortcut and eliminate the need to have to do a bunch of calculations. So it's a cosine graph. First cosine number is 1 times this multiplier. It means I'm going to start at -2. 1 times -2 starts me right there. The next number, it's actually pi over 4. This angle right here is pi over 4. That's what you'd plug in. But times the 2 is going to take me up to pi over 2. That's how that's going to work, but we're getting 0 times the negative 2 is 0. The next value you plug in, you're going to look at the cosine number of negative 1 times negative 2 is positive 2. Continue the pattern, the next number is going to be 0, and the next number is going to be 1 times the negative 2. It's going to be right there. So that's my cosine wave with a flip. Okay? Now you can draw a dotted line through there if you want to, but I'm just going to go ahead and shift. We want to shift everything to the left by pi over 2. Now keep in mind the way this graph paper is drawn, pi over 2 is 2 tick marks. So shift everything to the left, pi over 2, or 2 tick marks. And it's going to look like that. Now I know that looks like a V shape, but make sure you're drawing your wave. And then let's just draw this. The directions say draw it over 2 periods. So let's just extend the pattern 2 periods, and that's it for this one. So the next dot would be here, and then here, and then here, and then here if we continue that pattern. Of course, you could always fill up the graph and draw all of the periods, but that's 2 periods of my cosine wave right there. All right, I see that 3 again. I'm going to change the 3. I don't like that 3, so I'm going to change the 3 to a 1/2. So change that 3 to a 1/2. That's going to affect the period. All right, I see this 3 in the front here, and that's fine. That's actually going to be an upshift. That tells me I'm shifting the whole curve up 3. And if you don't see that, think about switching it around. If you wrote the equation as negative 2 cosine 1/2 x plus 3, that is a positive 3 after all. Maybe it looks more like an upshift. We're shifting the whole thing up 3. As for the amplitude, well, let's rewrite it. Rewrite it without the shifting. Y equals negative 2 cosine 1/2 x. I took out all the shifting. That's what it would look like. The amplitude is going to be 2 with a flip. And the period is going to be 2 pi over b. That's 2 pi over 1/2. Divide fractions, so we're going to multiply by the reciprocal. 2 pi times 2 is 4 pi. All right, so we've got a period of 4 pi, and that's actually good news because the longer the period is, the less dots we have to do. I know your graph paper doesn't go to 4 pi, but big deal. We'll just extend it out. Okay. You could change your scale, I suppose, if you wanted to, or extend your graph. We're going to need to go to 4 pi. So the period is 4 pi. I'm going to mark that 4 pi and half again. Those are my 4 marks that are going to take me back to my circle and take me back to these numbers again. We're constantly going back to these numbers over and over again. So this is a cosine number. You look at your first cosine is 1 times your multiplier of negative 2. So 1 times negative 2 is going to give me negative 2. That's where we'll start. And then your next cosine number is 0 times negative 2 is 0. Put it on that tick mark. And then your next cosine number, negative 1, times your negative 2 is positive 2. Once you fill out the pattern, you don't have to do any more multiplication. The next cosine number is 0 times negative 2 will give me 0. And then you go back to positive 1 times your negative 2 is negative 2. So right there. All right, that's our regular cosine wave with a flip and an amplitude of 2. And we haven't shifted it yet, but now we're going to shift everything. Okay, so what did we say? Shift everything up 3. So take all of your dots and shift them up 3. There we go. 1, 2, 3. There we go. 1, 2, 3, and 3, and 1, 2, 3. Now it's going to be equal to 1 or even with 1. That's one period of that. Follow your pattern, and you're going to have those dots as well. Draw a smooth curve through your shifted dots. It's going to look something like that. Okay. Let's try number 5 now. Okay. Number 5, I'm going to leave this one alone, I think. You should be able to see pretty quickly that there's going to be a downshift. So we're going down 1. And you can see your amplitude is 2, but we'll get to that in a minute. I want to look at my phase shift. If you can do that in your head, that's great. It's going to be negative pi over 4. If you need to think about it as what makes 0, maybe that helps. Subtract pi. And divide by 4. So your 0 there is negative pi over 4, and that's how you should know that this is left. It's left pi over 4. So we've got 2 shifts. We're going to have to go down 1 and left pi over 4. So imagine what the equation would be like without the shifting. Taking out the shifting, you'd have y equals 2 sine 4x. I have to leave that 4 in there because that's going to be what determines the period. Amplitude is 2, and the period is 2 pi over b, or 2 pi over 4, which reduces to pi over 2. So that's actually kind of a difficult result, a period of pi over 2. Because, watch what happens when you mark that. Pi over 2 is right there. That's pi over 2. You cut it in half right there is pi over 4, but you cut it in half again and you're in between marks. And that's okay, it's just kind of hard to do on this graph paper. If you were doing it by hand without graph paper, it'd probably be easier to do. But we take that pi over 2, cut it in half, and half again. Those are our dots. Okay? So again, go back to that circle. And the first sine number is 0. And then the next sine number is 1, right? Here is 0, here's 1. But don't forget to multiply by the amplitude. And you're going to have an x right there. Okay, you got to pay real close attention. This is hard to do, hard to keep track of. Okay, the next sine number, y number, is 0 times the 2, still puts me at 0. And then the next sine number is negative 1 times 2 is negative 2. And then the next sine number is going to take me back to 0. There we go. So there's my non-shifted sine curve that has amplitude 2 and period pi over 2. Now I'm going to have to shift it. Okay? So down 1 is easy enough, but left pi over 4, remember how many marks pi over 4 was? 1 tick mark, okay? Not 1 half tick mark. Notice I made a little bitty half tick mark in green there, okay? We're talking about one of the original boxes. So basically we're going down 1 and left 1 tick mark. So I'm going to have a dot there, okay? And my second x, when you go down 1 and left 1, it puts you halfway in between. See how that second x is halfway in between? My second dot will be halfway in between. The third x, down 1 and left 1. The fourth x is halfway in between. So when you go down 1 and left 1, you should still be halfway in between. The last x, down 1 and left 1, right there. Okay, so there's one period of the graph. Okay, that's pretty hard to draw because everything's so compact and tight in there. Let's just follow the original instructions, and since it says 2 periods, let's just do 2 periods of this graph, okay? So the next one, if you go up, you're going to be halfway in between, and then back down, and then down, you're halfway in between, and then back up to your baseline. There's 2 periods of that sine curve. Now, obviously, you could extend that out, and you could finish that and draw the whole thing, but that's kind of tough with it being so compact because the period is so small. Think about this question. What's the maximum value of this? The maximum value of this graph is 1, right? What's the minimum? The minimum of this is -3. You're going to see that question at some point. And, you know, you can really, if you look at the equation here, you can kind of tell. If you find the amplitude is 2, and you're going to shift everything down 1, that would lead you right to these same numbers without even having to draw the graph.